Alright class, here we are at the review number 2 worksheet for the quadratic functions unit. Question number 26. For the equation f of x equals negative 3, x minus 5 squared plus 2, is the vertex a minimum or maximum point on the parabola? Minimum or maximum? This question is missed very often by students who are not paying attention to how to solve this problem. And the easiest way to solve this problem is look at your a value. Your a value here is negative 3. That means the parabola opens down. That means your vertex is at the top of the parabola, and that is a maximum point. That's the highest point on the parabola. So that means this has to be a maximum. If the a value was positive, then the parabola would open up and the vertex would be at the bottom of the parabola, or the minimum. So when it asks the question, how do you know? Okay, because the way you answer this is because a is negative. There's your evidence to support what you're saying about the vertex. Because a is negative, that means the parabola opens down. And the vertex, I'm not going to write the whole word, and the vertex is at the, and I'll just put one letter here, is at the top. So there you go. Because a is negative, the parabola opens down and the vertex is at the top. You could write that all kinds of ways, just as long as you give me evidence to support how do you know it is the maximum point. Alright, is this parabola stretched or compressed? Well, in this case, if you look at the a value is negative 3, that means the absolute value of a is equal to 3, because absolute value means just look at the positive part. And we know that when the absolute value of a is greater than 1, we have a stretch. So it is stretched. And the question is, how do you know? You can write this answer however you want. Here's my evidence. So I would write something like this. Because the absolute value of a is greater than 1, I know the parabola is stretched. That's the easiest way to describe it. Alright, let's go to the next one, number 27. Change the function f of x. Oh, back to that previous one. And then, of course, if your absolute value of a was less than 1, like 0.5 or 1/4 or 3/4, you would say you know it's compressed because the absolute value of a is less than 1. All right, number 27. Change this function to standard form. Well, class, the easiest thing to remember on this is standard form means it is simplified. It's completely simplified. That means multiply everything out, add, subtract whatever you can, combine like terms, and that will give you standard form. So we're going to go ahead and do this. Let's step this out. Here is our function f of x equals x plus 3. I'm going to start my work right now. I know that this exponent means it's x plus 3 times x plus 3. Remember, an exponent is a shorthand way of writing multiplication when you're multiplying the same thing over and over again. 7 to the 4th power just means 7 times 7 times 7 times 7. We're just lazy mathematicians. We don't want to write that whole thing, so we write 7 to the 4th. So x plus 3 squared just means x plus 3 times x plus 3. I'll put the 7 at the end here. Let's do our binomial multiplication. Take the first term of the first binomial, multiply it times the second binomial. Take the second term of the first binomial, multiply by the second binomial, and don't forget to put the negative 7 on the end. I'm sorry, subtracting 7. Alright, let's do the next step. We're going to multiply monomial times binomial. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. And we've got this subtract 7 here. And now we can see we've got some like terms. These are like terms because they have the same variable with the same exponent. These are like terms because they don't have a variable. They are constants. So our final answer is going to be x squared. 3x plus 3x is 6x, and 9 minus 7 is positive 2. There we go. Let's take a look at the next one. Alright, we got change the function to standard form. I'm going to do the first step for you as a reminder. You should, of course, be trying these on your own. There's going to be f of x is equal to negative 2. This square means multiply this binomial twice. And then I'm going to go ahead and give you the answer, and you could check this once you get your work done. The final answer should be negative 2x squared plus 20x minus 42. Check out your steps, see if you can get that answer. You should be able to, and if not, if you need help on that, just talk to me in class and I'll take care of that with you. Alright, let's go to 29 and 30. Let's see how fast we can get these done. Number 29, using f of x equals a times x minus h squared plus k. Class, that's just the vertex form quadratic. So I'm just going to write here, this is just vertex form. Okay, and the point 0, 3, which happens to be right here. Here's our point 0, 3 right here. Find the function of the graph below. Actually, I'm going to do something here. Let's make this readable. So I'm going to erase part of this. We can actually see that much better. I know you can't do that on your paper, but I'm going to make sure you guys can see this. That's 0, 3. Okay, find the function of the graph below. Well, the way we find the function of a graph is we find the vertex. We find any point on the graph. In this case, they want us to use 0, 3. And from those 2 points, we find what our a value is. Once we find our a value, we know our h value. That comes from the vertex. We know our k value. That comes from the vertex. And we'll have our function. So let's find our vertex. Our vertex is going to be at, I'm going to go ahead and erase the spot here so we can see this better. Our vertex is going to be at, looks like it's negative 2, negative 1. Alright, so let's label these. We know the vertex is going to give us our h value and our k value, and the other point is going to give us our x value and our y value. So let's write our equation and plug in our 4 things and then solve for a. Here we go. So f of x is equal to a times x minus h squared plus k. We always start with that vertex form quadratic. Let's plug in our values. So f of x, that's the same as y. So our y value is over here, that's 3, equals a, we don't know what a is, x is equal to 0. H is negative 2, but remember when h goes into the equation, because there's a subtraction here, it will change to positive 2 squared, and then our k value is negative 1. So far so good. Next step. Let's go ahead and do parentheses first. We're going to use PEMDAS. 3 equals a. And then our parentheses here, oops, let's move that over. It's a. In our parentheses, we've got 2, and we're going to square that 2. Next step is, let's go ahead and do the exponent. So PEMDAS, parentheses first, then exponents if we have them. So 3 equals, now this is going to be a, and 2 squared is 4. I'm going to write that in the front now, so I'm writing it mathematically correct. You could write a 4 as well. Just make sure you know those are multiplied together and not added. Okay, next step is we're going to move the 1 to the other side by adding 1. And I've got 4 equals 4a. And then the next step is we're going to divide, because we want to get a by itself. Divide both sides by 4. And we've got 4 divided by 4 is 1. When you divide this term 4a by 4, the 4's cancel each other because they turn to 1. And that just changes to a. And that's what we're looking for. We solved for a. Now once we have a, we're pretty much done. All we do now is we go back to our vertex form, plug in a, plug in h, plug in k, and you've got the function. So for our final answer, f of x equals a, which is 1, times x. Remember, our h value was -2, so it turns out to be +2 in the equation, squared. And then our k value is -1. And there's our equation for question number 29. All right, question number 30. And by the way, remember on this one, I notice a lot of students will want to plug in the x value as well. When you turn this back into a function, y remains a variable, f of x, and x remains a variable. All you replace is a, h, and k. All right, last equation, number 30. Find the function of the graph below. All right, well, they've given us some information in here. They gave us a known point at 1, -3. All we got to do right now is find our vertex. Let's do that right now. So let's put our vertex right here. Our vertex is at -2, -2 and -1. So -2 and -1. Okay, and we know that's going to give us our h and our k, and this known point is going to give us our x and our y. And some of you have learned this by making this mistake. You can't flip these around. You can't make 1, -3 h and k. Why would you ever do that? That's not the vertex. H and k always come from the vertex. The other point you pick anywhere on the parabola, if you know any other point, that's going to be your x and your y. So here's our base equation. F of x equals a times x minus h squared plus k. Let's plug in the 4 values that we know. F of x is the same as our y value here, which is -3. We don't know what a is. X is equal to 1. H is -2, but that will turn to positive in our equation because we're going to flip the sign here. Squared, and our k value is -1. All right, let's follow the rules of PEMDAS. Parenthesis first. -3 equals a. 1 plus 2 is 3. Squared minus 1. Now we'll do the e in PEMDAS. Exponents. -3 equals 3 squared is 9, and we're going to put that in the front of a. 9a minus 1. All right, our goal is to get a by itself. We're going to get rid of this constant first by adding 1 to both sides. -3 plus 1 is actually -2 equals 9a. And then our last step is we're going to divide both sides by 9. That means this value here is going to be -2 over 9, and this value here, the 9 cancels the 9, that changes to 1. So our final answer is here, I'm going to write this out in a separate place. We pick a different color. Let's pick dark blue. So a is equal to -2 divided by 9. And now we'll write our function. F of x equals a, which is -2 divided by 9, times x. Our h value was -2, so that changes to +2 squared, and our k value was -1. And that is our final solution. Again, if you want to just see how this plays out, there's our a, there's our h, and there is our k value. All right, we are done with question number 30.